Alrighty, Algebra 2, time for example 2. So this is just another way of asking a similar question to example 1. So in example 1, we were asked this question symbolically, but we can also ask this question in the way that it's expressed here, which is finding the product, because product means multiply, right? Of x plus 2 over x to the fourth minus 16, and x cubed plus 4x squared minus 12x. So the first thing I'm going to do is rewrite this problem so that it's expressed in the way that I would like it to be. Times x cubed plus 4x squared minus 12x. And since this expression is not a fraction here, I can turn it into a fraction and just put all of that over 1. All right, so let's go through our steps and start factoring. So there's nothing to factor out of the numerator in that first fraction, so I'm just going to copy that down again. And I notice here that the denominator is actually a difference of squares. So I'm going to rewrite this as x squared plus 4 and x squared minus 4. And when I do that, I even notice here that this is another difference of squares. So actually, I'm going to rewrite this down. I'm going to take this a step down here. And I've got x squared plus 4. And I've also got now x minus 2 times x plus 2. Because I found difference of squares here. And that's where these two expressions came from. And then difference of squares here again, and that's where these two expressions came from. All right, so now I've factored everything in my first fraction. Let's move on to the second fraction. So in the second fraction, I notice that I've got an x in every single term in my numerator. So I'm going to go ahead and factor out an x to start off with. So when I factor out an x, I'm left with x times x squared plus 4x minus 12 all over 1. Okay, so now what I notice here is that I've got a quadratic in my numerator that I can factor out again. So remember, we're looking for two numbers that add to positive 4 and multiply to negative 12. So I'm going to have two sets of parentheses, an x at the front of both of those. I know that one of my factors has to be positive, one has to be negative because they multiply to a negative number. And I know that the correct combination of that has to be positive 6 and negative 2, because 6 times negative 2 is going to give us negative 12. And then when I add those two numbers together, they give us that positive 4 all over 1. Okay, so now I've factored everything. Oops. Let's go ahead and see what we can start reducing. So I notice that I've got an x plus 2 in my numerator here and an x plus 2 in my denominator here, so that can cancel. I see that I've got an x minus 2 here and an x minus 2 here, so let's go ahead and clean this up. So let's see what I'm left with when I multiply straight across is this becomes a 1. So I have 1 times x times x plus 6 in my numerator, and in my denominator I'm just left with that x squared plus 4. All right, and then if we wanted to, we could distribute that x, and we would be left with x squared plus 6x all over x squared plus 4. And here is our simplified version. Okay, and now we also have to state the restrictions. So for this, we would say that our domain would be all x such that x could never equal positive or negative 2, and I'm just going to shorthand it just like that, because if I were to substitute in a positive 2 here, I'd be left with a 0. If I put in a negative 2 here, this is where that 0 would come from. And that is just about it, because if I put in a positive or negative 2 in for this x as well, then I'd also be left with a 0. So these are all our restrictions.